Hello Year 12 and welcome to the 7th video here in our series on trig functions. We want to look today at the integration of trig functions. Previously we've looked at differentiating, derivatives, differentiating. Okay, and integrating is, as before, pretty much the reverse of that. One thing to watch out for are positive and negatives. I'm avoiding the word sign here because that gets a bit ambiguous. Be careful of the positives and negatives, right? Don't confuse differentiating and integrating when we do this. Right, we'll see how that plays out, possibly here in the first example. So, first of all, I want a definite integral from 0 to pi on 3 of sine x. So, the integral of sine x is negative cos. Right, so it's negative cos x from 0 to pi on 3. Okay, now this equals the negative cos of pi on 3 minus the negative cos of 0. Okay, so be careful with the double negatives here. I don't usually write them much out, but it's just too easy to make a mistake. Now, if you need a reminder for cos pi on 3, 1 root 2, root 3, silly me. Oh, all over the shop. That's a 2 there, of course. Okay, 1, 2, root 3. Now, the cos of pi over 3 is a half, so it's negative 1 over 2. And the cos of 0 equals 1, so it's minus the negative, it's minus negative 1, it's plus 1, equals 1 half. Okay. Be careful of the positives and negatives in that. Right, there's the first example there for integrating trig functions. Now, should you have to integrate something like tan or cot, right, which of course is the reciprocal of tan, what we need to do, right, what we want to do is to treat this as sine over cos or cos over sine, and to treat cos as the derivative of sine, or vice versa. Right, it's going to help us out here. I'll explain that a little bit more here. So this equals the integral of cos over sine, cos x over sine x. So cot is 1 over tan, tan is sine over cos, so cot is cos over sine. Now remember that, in fact I'm going to say, let u equals sine x. You don't have to do this, but this hopefully will make a bit more sense. For u prime equals cos x. Okay, differentiate sine, you get cos. So what I want to do then is I want to integrate equals the integral of u prime on u dx. And do you remember that that is, right, if I've got the differential of a function over a function, then that is equal to the log, the natural log. So log base log base e of u prime on u of cos x on sine x. Of sine x. Right, the log of the bottom one there is the log base e of sine x. There we go. That's our answer. So we break tan into sine over cos, break cos into cos over sine, and we remember that relationship between those two, that one is the differential of the other, or similar to the differential of the other. Rightio? So that is integrating trig functions. Integrating trig functions, that's really pretty tricky as far as these go. When you get a log involved, most of them are going to be something like this. Right? Nice and straightforward. Okay, that's a nice change. See you in class.